Welcome to Chapter 5, where we are going to do a lot more with identities. Before we jump into Section 5.1, I want to go back to Section 1.5, where we talked about identities quite a while ago, and just kind of review a couple of things. And by the way, I suggest you go back and review your notes in this section. But what I want to specifically look at right now is verifying an equation is an identity. And there's some important instruction or information here. Let's just read it together. Start with the more complicated side and use algebra and the fundamental identities to turn it into the other side. Do not work with both sides at the same time. Although, if you want to go off on scratch paper and do that, I do that too. But the actual proof you submit needs to show you starting with one side and working towards the other side. So, for example, in this first example here, verify the identity cosecant theta times tangent theta equals secant theta. Notice I start with the left-hand side because that's more complicated. I write it down, and then I say what it's equal to. And what I did in this case is changed everything to sines and cosines. Then I did a little algebra canceling the signs. Then I say equals, and the next expression that's equal to what I started with is 1 over cosine theta, and then finally equals, and your last step should be equals the other side. What you don't want to do is work with both sides like this. So don't start out by writing down the identity and then working with both sides and then saying, oh, look, they're equal. And the reason for this is it looks like circular reasoning, and here's why. You start out saying cosecant theta tangent theta equals secant theta. Well, you can't start from the thing you're trying to prove. That's circular. So, for example, suppose today is Tuesday, and I want to prove to you it's Tuesday. I can't say today is Tuesday. I can't start there and say today is Tuesday, therefore tomorrow is Wednesday, and since tomorrow is Wednesday, today must be Tuesday. That proves nothing because I started out by assuming the thing I'm trying to prove. And that's what it looks like when you write down the identity as your first step and work with both sides. You're starting out assuming the thing you're trying to prove is already true. So it's really important not to do that. Let's go down a little further because there's something else I pointed out for what not to do. Okay, and that is don't start in doing things to the side that you're starting with. So in this example, I think I did it the correct way just above there. Yeah, so in this example, the left-hand side is clearly the most complicated. So I started there. I wrote that side down, and then I put equals and started doing stuff to it. So what I did in this case was I wanted to get a common denominator, so I multiplied both of the fractions by whatever the denominator needed. What you don't want to do is start there, start with manipulating the side that you're starting with, and just put an arrow up to that side. No, you have to actually write the side down in its original form without doing anything to it, and then say equals, and you can start doing things to it. And I think that was all I wanted us to look at in this section. So let's jump forward to today, 5.1, proving identities. First of all, what's an identity? Well, two functions f and g are said to be identically equal if f of x, my typing today is really off, f of x is equal to g of x for every value of x for which both functions are defined. Such an equation, in other words, one that's true for all x values in the domain, is called an identity. Now, we've learned quite a few identities so far, and I've summarized them here just for your convenience. We've got our reciprocal and quotient identities, the Pythagorean identities, the odd-even identities, the ones that are called the periodic identities. And here's some super good advice from a textbook. I think it's not our current textbook, but a textbook. And that is these identities, the ones above. These identities, by the way, they're often called the fundamental trig identities. That's how important they are. Anyway, they should not be merely memorized, but should be known, just as you know your name rather than you've memorized it. In other words, you want to be so familiar with them that you recognize variations of them. For example, you're so familiar with sine squared plus cosine squared equals 1 that you recognize that sine squared of x equals 1 minus cosine squared of x is just a variation on that. Just as you know that someone who's named Jonathan might be called John. To establish identities, as we just talked about briefly, start with the more complicated side, and then you're going to use stuff like algebra, algebraic manipulations such as LCDs and that kind of thing. And together with the fundamental identities, those are the ones on this page, to turn the one side into the other side. Do not work with both sides at the same time, except perhaps on scratch paper. In the next video, we'll do some examples, so I'll see you there.